Welcome back, Physical Science 20. This is video 6.3, the mole, a unit for counting. So this is the beginning of FC2, and the first thing we look at here is something referred to as the mole. So before we look at what the mole is, we need to look at a few other things first of all. So for example, how molecules, atoms, etc. come together. So we can see we look at the proportions in which they act. So for example, one molecule of hydrogen, one molecule of chlorine could come together to make two molecules of hydrochloric acid. So they're incredibly small, too small to see. Therefore, how do we know that we have one hydrogen molecule, one chlorine molecule? So this, the reaction figure 1, for example, represents an astronomically large number of reacting molecules, and yet chemists can combine just the right quantities of hydrogen to make chlorine. So counting them directly would not be technically possible because they're too darn small to see. If it were possible, the more molecules in the so if we here they talk about having a flask, and of course here with gases, one molecule. What happens here is that 1 liter and 1 liter is equivalent to this ratio here, and we'll see that later on when we look at molar volume. So if we were to count individual molecules, etc., it would take a lifetime. Therefore, there needs to be a more convenient way to calculate such things. Now, this booklet refers to entities, which refer to the types of particles that we're looking at. And the next page we'll go through exactly what type of particles are we talking about here when we have a chemical reaction such as this. Okay, so to take a look at this, make it very easy here. Let's say we have a hardware store in which we have it measuring nails the old-fashioned way. In other words, you don't count out individual nails, or there are no packages of pre-counted nails. You just simply mass out how many nails you have. And of course, in order to figure out how many nails you have at the counter, the person working the cash register would not count up each individual nails, but he or she would mass the bag of nails. And of course, there'd have to be an indication somewhere of the average mass of one nail. So as you can see, we could get the number of nails by calculating those, and we'd get very close to a whole number. The extra 0.015 would likely be the mass of the bag itself. Okay, so if we knew the average mass of a single nail, or we could figure out how many nails you'd have in a bag, or tennis balls, golf balls, etc. So that's what this page is going through. And of course, there's many applications of counting things by their mass. For example, coins, in a coin register, etc. Dumping a bunch of quarters in a bucket by mass, you can figure out how many quarters there are by knowing what the average mass of one quarter is. So sorting and counting money, etc., that's a way of counting by using mass. Okay, so with that we move on to here, counting by looking at mass. So a dozen is a commonly known unit that we all are familiar with. 1 dozen equals 12 things. A 6-pack equals 6 things. A ream, stacks of paper come in reams, and we know that they are 500 sheets. 1 hour, 60 things, etc. But when we're talking about atoms and molecules, they are so small that we need a large amount in order to detect them and make them measurable. This is where the mole comes into play. Now it represents a huge number of things. 6.02 times 10 to the 23rd things or entities or particles. There is a shortened version for mole. It's just MOL, because who wants to spend the extra time writing that extra E? It's also referred to as Avogadro's constant, named after Amedeo Avogadro, who first experimented with this. So that is that number. Now, why did they not choose a more convenient number? If you take a look here, it's based on something. It's based on a known standard, and that standard is based on 12 grams of carbon. So if you had exactly 12 grams of carbon, that would be considered to be 6.02 times 10 to the 23rd. You would need that many carbon atoms thrown on a balance to to have it measure 12 grams. And what's interesting, of course, what we'll see in the next section is the molar mass, and if you look at the periodic table, the atomic mass of carbon is 12. So we'll see some interesting things with that in a bit. So remember that the mole is a counting unit, just like the dozen. If you ever get freaked out about the mole, just think of the word dozen. It's exactly like that. It just represents the number of things. So instead of using dozens, chemists use the mole. So if we take a look at this example here, I think we have a mole of carbons, a mole of sulfurs. So we both have the same number of atoms here. We have 6.02 times 10 to the 23rd carbons. We have 6.02 times 10 to the 23rd sulfurs. But of course they have different mass. Similarly, if I had a dozen golf balls compared to a dozen ping pong balls, it doesn't take much of an imagination to realize that the dozen golf balls will have a bigger mass. Similarly here, a mole of sulfur atoms would have a bigger mass than a mole of carbons. What's equal is how many each individual atoms we have. What's different is the mass and also the volume. Okay, so just trying to show you that the mole is a number. It represents the number of things. So here we have other things here too. These all represent a mole of different particles: sucrose, sodium chloride, and carbon. But you can see that they would have different masses. Same number of each individual particles, but different mass. How big is the mole? An interesting green pea analogy here. If you had 100 green peas, it fills a teacup. If you had 1,000,000, it would fill a refrigerator. Until eventually, if you go down to 1/6 of a mole, 250 planets like Earth covered 1 meter deep in peas. So it's a huge number. You would never count it in a single lifetime. Okay, and before we do calculations involving the mole, just kind of a refresher on your calculator and scientific notation. When looking at scientific notation, for example, numbers like 2 times 10 to the 5, instead of typing 2 times 10 exponent 5, use your EXP or your EE button. So check your calculator to make sure you have that, and that does the work for you. It represents times 10 to the whatever exponent you're about to enter. So to type in 2 times 10 to the 5, it would be 2 EXP 5, then multiplied by the next number. So use the EXP button because you'll run into issues, especially if the scientific notation number is in the denominator of the problem that's in question. Okay, and similarly here, 9 EXP4 divided by 3 EXP negative 6. Of course, use your plus minus button for that part as well. So you could maybe run through these, make sure you get the right answers. They're stated right here. In summary, the mole is a counting unit just like the dozen. The mole is the SI unit for the amount of stuff, the amount of substance. It's based on exactly 12 grams of the carbon-12 isotope, and 1 mole represents 6.02 times 10 to the 23rd things. So we're going to be measuring by counting, etc., as was mentioned earlier on, and we'll go from there. Now, the questions I want you to do are 1 to 5. To give you a little bit of a hint here, with number 3, a chemist pours 1 mole of zinc granules and 1 mole of zinc chloride powder in a beaker. So imagine the granules as little spheres that are fairly big that you can see, whereas the powder are individual grains of powder, just like if you sprinkle salt, individual crystal. So you're comparing granules to little crystals here, and of course, what do they have in common? If you have a mole of this and a mole of this, I'm kind of illustrating it as 5 granules versus 5 crystals, so hopefully you'll be able to answer that. Over here, use the same logic for 5b to calculate the number of molecules. So you should be able to run through those questions. Just go back, read what we went through, and it should be no issue. Okay, we'll see you again.